Hello student, good morning. I am Dr.A.K, Professor of Chemistry. Today I am going to discuss preparation of alkyne. Preparation of alkyne. Last class I have discussed introduction of alkynes, nomenclature, isomerism and structure of triple bond. Now this structure of triple bond I have discussed and sent this diagram also. Now I am going to discuss preparation of alkynes. First preparation is from calcium carbide. This is a very important preparation of alkynes. How we will prepare it from the carbide, calcium carbide? I am telling you, actually this is on industrial scale, large quantity. Ethine is prepared by treating calcium carbide with water. Just to take calcium carbide is just like a stone, and just to put water, acetylene gas will come, and this acetylene gas will burn. If you put fire, it will begin to burn. Okay. Then how will you make the calcium carbide? Calcium carbide is prepared by heating quicklime with coke. Quicklime with coke. And how will make the quicklime? Then quicklime can be obtained from heating limestone. Limestone means calcium carbonate. Calcium carbonate, if you will heat, then you will get two products. First calcium oxide and second is carbon dioxide. Now this calcium oxide is called quicklime. And now calcium oxide you got, that is a quicklime. Now you got, then this quicklime plus coke. Coke means carbon. If you will mix both calcium oxide plus coke means 3C, then you will get CaC2 plus CO gas. CaC2 means calcium carbide. CaC2 is called calcium carbide, always you remember. CaO plus 3C, CaC2 plus CO. Okay. Now calcium carbide you got. Then calcium carbide plus water, 2H2O, CaC2 plus 2H2O. You will get two products. First main product is acetylene, C2H2, first product. Other product you will get calcium hydroxide. Correct? Then this I have told you, preparation of ethine. Ethine, first example of ethine is acetylene gas. Now second I am taking second preparation from vicinal dihalides. Vicinal dihalide on treatment with alcoholic potassium hydroxide undergo dehydrohalogenation. Hydrohalogenation. Dehydro means HX will go. Dehydrohalogenation. Halogenation, you know that addition of HX, and dehydrohalogenation means it will go. One molecule of hydrogen halide is eliminated. One molecule of hydrogen halide HX is eliminated to form alkynyl halide. Okay, it will form alkynyl halide, which on treatment with sodamide means NaNH2 gives alkyne. This is also important reaction. I am telling you, just you take dihalide. As for example, CH2Br, again CH2Br, both CC is joined by single bond. CH2Br, again single bond, again CH2Br. This is the dihalide, vicinal dihalide, because both bromine atom are just at adjacent carbon continuously together, okay, very close. First carbon bromine and second carbon also bromine. That's why it is called vicinal dihalide. Then this vicinal dihalide plus KOH, what it will give? Actually, this reaction will take place in the presence of soda amide, okay. And this CH2 again CH2, okay, CH2Br again CH2Br, and both CH2Br is joined by carbon, this single bond. Both carbon is joined by single bond, CH2Br again CH2Br, and both CH2Br is joined by a single bond. Then now very easy things reaction, that what will happen? HBr, one Br on one H, one Br and one H, both will form HBr, and it will go outside, means eliminated. Then from one carbon hydrogen gone, from other carbon bromine gone. Then obviously now each carbon one electron is there, then they will make double bond. Hence you will get CH2Br you will get, means ethyl bromide you will get, okay. One carbon bromine will be remaining, and other carbon bromine that will, you can say, go. They will, that carbon bromine from one carbon and one hydrogen from other carbon, they will form HBr. And because it went, then when bond broken, that time both carbon got one electron. Hence now single bond became double bond. Ethyl bromide, it formed these things, CH2CHY, ethylene bromide, okay. It forms ethylene bromide, and this ethylene bromide means CH2Br, okay. This CH2 again CH2Br, this form, this is actually alkynyl halide in general, alkynyl halide, or particularly you can tell ethylene bromide, because carbon double bond is there. Now you have to form triple bond. Double bond you got it, from single bond you got now double bond. Now from double bond you want triple bond. Then now next step, it will react with sodium amide. Then here what will happen? It will this amide will take in sodium amide, NaNH2, Na plus NH2 minus. In this NH2 actually it will take one hydrogen from ethylene bromide, one hydrogen it will take. Then NH2 will convert to NH3, Na plus NH2 minus, and hydrogen is H plus when it will come. Then it will form NH3, and Na what it will do? Sodium plus, it will take bromine, it will take Br minus, bond will break from ethylene bromide, two bond will break. Then when bond will break, then carbon will get 2 electron. Each carbon will get 2 electron, okay. Then they will make, now double was there, then each carbon has one electron. Then they will make triple bond, and other product will be ammonia gas, NH3, and other product will be NaBr. Na plus, bromine will come with electron, Br minus, bromide ion, then Na plus, Br minus. It will form NaBr. But main product is acetylene, because on each carbon only one hydrogen will remain. Okay, then now double bond converted to triple bond, and it formed acetylene gas, CH, triple bond CH. This I have told the important preparation of alkyne. Now I am going to discuss physical properties of alkyne. Here physical properties, now I am going to tell physical properties of alkynes follow the same trend of alkene and alkanes. First three members are gases, and the next 8 are liquids. And the higher one are solid. Reason, if carbon number will be less, then like up to 4 you can tell, 3 up to maximum up to 4 it will go in a vapor form, because carbons are less, means molecular mass will be less. After that, as the carbon number will increase, then gas will convert to liquid. Okay, they will form liquid. Now it will not able to escape, it will not able to go to the you can say atmosphere, because of heaviness, molecular weight increased, and again further molecular weight will increase, means more number of carbon will increase, then it will solidify, it will become solid. Then all alkynes are colorless. Other things, all alkynes are colorless, no color. Ethylene has characteristics odor. Its smell is particular, very irritating odor will come. Garlic like a smell will come, garlic like. Okay, ethylene has characteristics odor. Other members are odorless, no odor. Only you can tell this acetylene is the one example that will give a special color, a special odor. Okay. Now I am telling you, ethine means acetylene. Ethine means acetylene. I am talking about only acetylene has a very peculiar odor, garlic like. Now others are, I told you, it is not this thing. All are odorless, no odor. And again I am telling you, alkynes are weaker polar in nature. Alkyne means here R you consider always. C, acetylene is there, CH, triple bond again CH. Then one H will go, and its place R will come, alkyl group. Maybe methyl, maybe ethyl, maybe propyl, maybe butyl. Both carbon also H will go, and its place some other group will come, particularly methyl, ethyl, propyl, butyl, like that way. Then here I am talking about that alkynes are weaker polar in nature. No polar you can tell, weaker, very weak charge will be there. They are lighter than water. It will not just if you put this alkynes on water, then they will swim like that. They will be upside. Okay, they are lighter than water and immiscible with water. it will not dissolve with water, but soluble in, where it will dissolve, then organic solution. It will dissolve in organic solvents like ether, carbon tetrachloride, benzene, all are liquid. All are used as a solvent. Carbon CCl4, carbon tetrachloride, benzene, ether, all are just like water, you can say it is also solvent. Then organic solvents, this all alkyne will dissolve in organic solvents like carbon tetrachloride, ether and benzene. Their melting point, boiling point and density increase with increase in molar mass. Means as the carbon number will increase, then all these things will increase. Melting point, MP, not member of parliament, MP. For chemist, MP means melting point. BP means not blood pressure. For doctor it is blood pressure, but for chemist, boiling point. Okay. Then melting point and boiling point and density increases with increase in molar mass of alkyne. Now I am going to discuss chemical properties. Okay. Alkynes show acidic nature, addition reaction and polymerization reactions. Okay, three main reactions are there. First is the addition reaction. First to understand acidic nature. It is a alkene, particularly acetylene are acidic. Any alkenes are have acidic nature, and it can go addition reaction as well as polymerization reaction. Now I will discuss acidic character of alkynes. Acidic characters of alkynes, YNE, remember, okay, alkynes. Then here, what happens here, why it has a acidic character? This question is asked in all competitive examination. Why alkynes show acidic character? Then here main reason I am telling you, I will brief you first. Here what will happen, that CC triple bond is there. Then there you know that sp hybridization is there. In alkane sp3, in alkene sp2, and in alkyne sp hybridization is there. Then carbon is making bond with hydrogen. Here in acetylene, then hydrogen has S character and carbon orbital is sp hybridized orbital. Then they are making S and sp bond. H has S orbital, then S and carbon has sp hybrid orbital. Then in S orbital and sp orbital, they are making bond. In other cases you have seen in alkane and alkyne, S and sp3, they were S orbital and sp3 orbital, they were making bond, S orbital of hydrogen. And in alkene, double bond, S and sp2. Then now here you can see slowly it will compare alkane, alkyne. Then alkyne had, you can tell, alkyne had less percentage, 1S, and there was sp3. Now in second case, S is the same. Now sp2 in alkene, sp2. S character is now increasing. And in third case, here S and sp. Then S character of hydrogen is increasing slowly. In alkane it was less, alkene was little more, now it is maximum here. Then S character of H has increased, correct? Then what will happen? Due to this increase of S character, what will happen? This alkyne will show acidic character. Okay. See, basic character means your loss of electron. Basic character means what? It can, any molecule can donate the electron. As for example, NH3, N has lone pair of electron, it can donate. Then that is the, you can say, basic nature. Here it is a reverse case. S character of H has increased. Then here it can donate the electron. Because here already you know that carbon-carbon triple bond is there, then more electrons are there. They can break easily. Correct? But these things, S character has increased. That is the main reason. And now I am telling you details. Okay. This sodium metal and sodamide. Sodium metal and sodamide means NaNH2 are a strong bases. You know why they are a strong bases? Sodium metal and sodamide, because sodium metal can lose the electron. That's why it is basic. Sodamide also NaNH2. N has lone pair of electron, it can lose. They are a strong bases. They react with ethyne. In the to form sodium acetylide. Na will join with acetylene. H will go and sodium will join. H will go and sodium will join. That's why it will form acetylide. Then here that H gone and sodium joined. It formed acetylide, sodium acetylide, with liberation of hydrogen gas. Hydrogen gas will come out. These reactions have not been observed in case of ethene and ethane. Alkane and in alkyne, this does not happen. This indicate that ethine is acidic in nature, because hydrogen was not coming out. This here hydrogen is going in the form of hydrogen, H2 gas. But alkane and alkene it was not happening. Then this show liberation of hydrogen gas. It shows that ethine means acetylene. That is a acidic. Alkyne is acidic in nature. Okay. Why this happens? Now I am telling you. Hydrogen. We know that hydrogen atoms in ethine are attached to the sp hybridized carbon atom. Already I told you, now again I am telling you. Here, hydrogen atoms in ethine are attached to the sp hybridized carbon atom, whereas they are attached to sp2 hybridized carbon atom in ethene, double bond, and sp3 hybridized carbon in ethane. Okay, but here S and sp bond is forming due to the maximum percentage of S character, 50% S character. The sp hybridized orbitals of carbon atoms in ethine molecules have highest electronegativity. It will take the electron. Okay, this is the important things. Here, sp hybridized orbitals of carbon atoms in ethine molecules have highest electronegativity. Then if it is a highest electronegativity, then obviously it will attract the electron. It will attract the electron. Then from where it will attract the electron? Then hydrogen electron. When hydrogen was attached, their electron it will attract. It will attract the electron. Okay, because sp in sp character one s and one p is there, 50-50, 50-50. That s have can say this particularly sp you can tell it became electronegative. Sp very most electronegative it became. That's why it will attract the hydrogen electron. Correct? This is the, due to this you can say highest electronegativity. These attract the shared electron pair of the CH bond of ethine. In CH bond, shared pair 2 electron was there, shared pair of electrons. Okay. Then this, due to the highest electronegativity, these attract the shared electron pair of the CH bond of ethine to a greater extent than that of the sp2 and sp3. Already I told you they are not able to attract alkane and alkene, but here they are able to attract. Okay. Thus in ethine, hydrogen atoms can be liberated as a proton. Leaving electron it will go hydrogen. Without electron means no electron is as a H plus it will go. Half H2 it will form. Okay. Half H2 means more are there than H2 it will form. 2 hydrogen, 2H means H2, hydrogen gas. Thus in ethine, hydrogen atoms can be liberated as protons more easily as compared to the ethene and ethane. There that possibilities are very less, but here it is more. It will be liberated. Okay. Hence hydrogen atoms of ethine attached to triply bond carbon atoms are acidic in nature, because hydrogen has given, hydrogen became basic and hydrogen was attached to the carbon, acetylene or ethine. Hence that will be called that for this acetylene alkyne is acidic. Hydrogen has actually lost the electron. Hydrogen which belonged to the this acetylene, that lost the hydrogen attached to the carbon. That means in acetylene hydrogen was there, and that hydrogen they are losing electron. They are behaving as a base. Correct? That's why H and H they will form hydrogen gas. Okay, H2. This is the, due to this it is called acidic. Hence hydrogen atoms of ethine attached to triply bonded carbon atoms are acidic in nature. Okay, this I have told you. Now reaction you can understand. Acetylene molecule easily you can write CH, and between the C triple bond is there, means you can write HC triple bond CH. Okay, always you can say triple bond will be with carbon. Okay, not with H. Then HC you write, near the bond C should come, HC, not first C and then H. That you can write anyone either right side only you can write HC and CH. Then both C will come close, then triple bond will form. Hence it is the way to write HC triple bond CH. Okay, this plus sodium Na, what will happen? First it will form monosodium ethanide, sodium ethanide, or if acetylene then acetinide. In general it is called monosodium ethanide. Why the word mono here? Because now there is a scope for 2 sodium can attach, one more hydrogen is remaining. That's why here mono term is used, monosodium ethanide, okay, or acetylide in case of acetylene, and plus half H2. That hydrogen will go as a half H2, okay. 1H means you can write half H2, no problem. Now, second step, what will happen? Now again, this ethanide, monosodium ethanide, again it can react with the another sodium. Now it will become disodium ethanide or disodium acetylide, plus again this half H2 and half H2, again it will form half H2, okay, and half H2 it can make H2, no problem, half H2 can write. Now this I told you, like that way you can take these things. Now in the place of H, suppose CH3 came, then it became what? Propyne, because 3 carbons are there, methyl group attached in the place of H, one methyl group came, then now it became propyne. Then same reaction will happen. This methyl group is not going to do anything, only triple bond is going to be disturbed, okay. Here triple bond will not disturb, means one more hydrogen is there in the second carbon triple bond. Then one carbon already methyl group came, that is suppose propane came. A methyl group came, it became propane. Then now one H is there with second carbon. That will again NaNH2 will come, reaction will take place with NaNH2. Then what will happen? That hydrogen will also go as a NH3, Na plus NH2 minus, sodium amide. Then NH2 will take that one hydrogen and it will form NH3, and sodium will be attached with the carbon. Then it will form sodium propionide. Okay, sodium attached with the carbon, hydrogen gone, in its place sodium came, okay, and there hydrogen went as a H plus, okay. This NH2 minus was there, NH2 minus, correct. Then that H was plus, H came as H plus, leaving the electron. Then it became NH2 became NH3, NH2 minus plus N plus H, it became NH3 gas, ammonia gas, NH3, and electron is on carbon. Now sodium is going Na plus, then carbon will give this electron to sodium, one electron. That's why it will form sodium propionide. These reactions are not shown by alkenes and alkanes. Question is asked. Whatever I am telling you, question is asked, just to remember or just note down these things also. These reactions are very, very important for all exam. Then these reactions are not shown by alkenes and alkanes, hence used for distinction between alkynes, alkene and alkanes. By this reaction, which one is, where is the triple bond, easily you can distinguish, okay, differences you can do, that which one is triple bond, means alkyne. What about this reaction with butane 1YNE? That also reaction will take place, but you have to think, there also reaction will take place. If 4 carbons are there, 4 carbon means one methyl group will attached. One CH3 came, with one hydrogen gone, one CH3 came, it became propane. Other carbon, 2 hydrogen was there, suppose second also is going and one methyl is coming, then total 4. Then what about reaction, this reaction? Now no hydrogen is there, then how hydrogen gas will come? It will not come. because no hydrogen is there, then no gas will come. Okay, this reaction is not possible in case of butane, because no hydrogen is there. Now this I am telling you, if you will compare alkenes and alkynes, their acidic character, which will now easily you can tell out of these three which are most acidic. Then now nothing to tell, you are knowing acetylene is most acidic than ethylene. Ethylene is more acidic than alkane. Out of three, if you will compare, then acetylene is more acidic than ethylene, and ethylene is more acidic than alkane. Question is asked. Okay. And now these things, if you will consider these things, acetylene and propylene and this not in Y and E. Now suppose you are talking about the acetylene, that is the alkyne, you can tell, alkyne, acetylene 2 carbon. Now propyne is there, propyne. Okay, one methyl group has come. Now other is butane, 4 carbon came, but triple bond is there. In all carbon triple bond is there. Then in comparison to this, which one is more acidic? Then now easily you can tell. All things I have told you. Acetylene is, in acetylene 2 hydrogen is there. On each carbon 1 H. Then most acidic. And in this propane, CH3, C, and again CH, carbon C and CH, triple bond is there, 1 hydrogen is there, only 1 hydrogen. That's why it has a second priority. Most acidic is when 2 hydrogen is there, and second when 1 hydrogen is remaining with carbon having triple bond, and third, that is the no hydrogen is there. In both hydrogen, in the place of both hydrogen, methyl group came, that became butane. Then carbon triple bond is there, and in that carbon no hydrogen is there, because both hydrogen has been replaced by CH3. Hence these are, you can say, no in acidic character 0, no acidic character. But here acetylene is the highest because 2 hydrogen is there, and propane, in propyne 1 hydrogen is there, that was second, and this last, third, that means highest is acetylene. Okay, acetylene is greater than propyne, and propyne is very greater than butane. Okay, now I am going to discuss addition reactions. Alkynes contain a triple bond, so they add up 2 molecules of dihydrogen, because a triple bond is there. Then 2 bond can break, both pi electron bond will break. Then if 1 bond will break, then 2 hydrogen can attach, 2 hydrogen atom can attach. If 2 bond will break, then 4 hydrogen atom can attach, means 2H2 will provide 4 hydrogen atom. Then here easily 2H2 can be attached, and triple bond will convert to single bond, means acetylene will convert to ethane, because each carbon 2 hydrogen is adding, then each carbon 3 hydrogen is there. Then now this triple bond converted to single bond, means it can form ethane. This question is also asked, conversion also asked. This is called conversion. How will you convert acetylene to ethane? This question is asked. Nowadays multiple choice question is asked. Otherwise in written examination, that is the subjective exam, they used to write show it by reaction. But here you should understand that now easily it can be formed. And also this can happen to halide also, hydrogen halide in the place of H2. HCl also you can tell, then 2 HCl can join, 2 HCl can join, HCl, HCl, correct, it can join. Okay, formation of addition product, formation of addition product takes place. How? I am telling you. Suppose carbon-carbon double triple bond is there, carbon-carbon triple bond is there, and HX, suppose HX halide reaction is going on, HX. Then what will happen? When one bond will break, then one carbon will get positive, other carbon will get negative, and HX, H is positive, X is negative, hence they will go, you can say opposite, they will each will go oppositely charged carbon ion. H is positive, it will go to the negative carbon. Z is negative, it will go to the positive carbon. That's then triple bond will become double bond. Means one H and one X joined. X may be fluorine, chlorine, bromine, iodine. Here it will be bromine, chlorine, bromine, iodine. Okay, and this reaction will take place. Triple bond became double bond. H and X joined. Okay, this is also called vinylic cation. When carbon is there, suppose first H will add. When H will add, then H plus, it attached to the carbon, negative carbon. Then one carbon will be positive. That's why in this situation, this step, intermediate step, you can tell, that is called vinylic cation. Only on this plus C plus cation, Z negative will join. Z negative means X negative will join. Okay, and it will form vinyl chloride. Okay, the addition product formed depend upon the stability of vinylic cation. Addition product, what type of product will be there, what product it will form. Now you have not written HH, simply you have kept this thing, valence electron free to join, only dash you have written, and HX just they have joined one carbon H, other carbon X they have joined, HX or HZ, whatever you want you can tell. But that is the bromine, bromide, chloride, bromide, iodide. Then addition product formed depends upon stability of vinylic cation. Addition in unsymmetrical alkynes. Addition in unsymmetrical, not symmetrical. Addition to unsymmetrical alkynes. Alkynes takes place according to Markovnikov rule. Always remember. Addition in unsymmetrical alkynes, not symmetrical, unsymmetrical alkynes takes place according to Markovnikov rule. Majority of the reaction of alkynes are examples of electrophilic addition reaction, means E plus. Carbon will give negative electron will give carbon. Because electrophilic means E plus will come, they require electrophilic reagent, you can tell, electrophile, that is called electrophile, they require electron, and carbon will give, because triple bond is there, loosely bound electrons are there, they can easily give. That's why this electrophile will come and they can get the electron from alkyne. Okay. Then now some I told you that this reaction will take place following the Markovnikov rule. They will follow this rule, Markovnikov rule. Now I am telling you first hydrogen. First to understand addition of hydrogen. Then CH between the carbon triple bond is there plus H2. This reaction will take place in the presence of either platinum or palladium or nickel, any one. Then automatically this H2 HH will join on each carbon 1 it will join. Now it became ethylene. Ethine became ethene, means double bond, means acetylene became ethylene. Again further hydrogen is there, one more H2 is there, then that will also join. Then now it became ethane, CH3, carbon single bond. Then this already I have discussed. Now addition of halogens. Addition of halogen already I told you. Here just suppose one example simply this thing, bromine, Br2 is there, Br2, Cl2, I2, like that way. Then here Br bond will break. Br bond will break. One will become Br plus, other will become Br minus. Okay, Br plus, Br minus, this bond will break, and again you can say it will go to the opposite carbon having charge. Opposite one may when bond will break, triple bond, one will have positive charge, other carbon will have negative charge. Bromine also, both bromine, one is positive, other is negative, then obviously they will go to the opposite carbon which was having opposite charge. Then now triple bond became double bond. It formed 1,2-dibromopropene. Suppose you have taken propene. Suppose you have not taken ethylene, you have taken propene, 3 carbons. Then now these two bromine atom will join to that carbon which have triple bond, CC there, not CH3, where it will go. CH3 already 3 are there is no question. Then always reaction will take place where bond is breaking. Now that on each carbon 1 bromine will go. Okay, and it will form CH3 CBr double bond CHBr. Correct? Because methyl group is attached, one hydrogen gone and its place CH3 came, then propane, it became propane. Then now that carbon where CH attached, no hydrogen is there, other carbon have 1 hydrogen, then in that hydrogen one bromine will attach and other bromine will attach. It will become CH3 CBr triple bond CBr. Okay, triple bond, not a double bond CBr. Triple became double bond, and it is called 1,2-dibromopropene. E, now propene double bond ENE, 1,2-dibromopropene. Now again double bond is there, that also can break. Then again suppose one more bromine is there, one more Br2 is there, then same way again it will, both carbon will go to the both bromine atom will go to the both carbon 1 correct. Then now it became 1 2 tetrabromopropane, because 3 carbon is there, each carbon to 2 bromine is there, each carbon on each carbon 2 bromine is attached. Then now 3 carbon is there, then it became 1 2 dash tetrabromopropane, because now all are single bond. Okay, reddish orange color of a solution of bromine in carbon tetrachloride is decolorized. This is used as a test of unsaturation. Already last class I have discussed. Bromine color is reddish orange color. That color, if you can say this gas will pass through this bromine, liquid bromine, then that liquid bromine will be generally in carbon tetrachloride. Then this gas is passed, then color of this reddish orange color of the solution of bromine in carbon tetrachloride, that will decolorize. That reddish orange color will go. It means bromine which was present in carbon tetrachloride now used up by this alkyne, means unsaturated. Hence this is the test of unsaturation. This question is also asked. Then now I have told you about this addition of H2 gas and addition of halogens. Also I discussed, you can say, addition of hydrogen halide. Three things I discussed: addition of hydrogen halide, HX, and also halogenation, that is the Br2, Cl2, I2, like that. Okay, then that also I have discussed halogens, addition of halogens, and third I have discussed addition of hydrogen, addition of halogens, addition of halides. Three: halides, hydrogen, and halogens. Halide, addition of halide, addition of hydrogen, addition of halogens. Okay, halide is different, halogen is different. Halide is HX and halogen is Cl2, Br2, I2, like that way. Now I am going to tell again. I want to tell you these things. Already I have discussed addition of hydrogen halide. Already I have told you, not required. Okay, discuss. I will not repeat it. But here one thing only you have to know, that now I have, in general I have told you HX will join. In general I have told you, but now I am telling you only particular. Okay, and this what will happen? Two molecules of hydrogen halide, as for example HCl, HBr, HI, add to the alkynes. What I told you in the same way, one will go to the one carbon, HCl, HBr, HI. One will have H plus, Br will have one negative. If it is HCl, H will have positive, Cl will negative, HI, H is positive, AI negative, I is negative. Then both carbon will have positive, negative, cation and anion. Then oppositely they will go and join. Then triple bond will become double bond, and further reaction, double bond become triple bond. Means this acetylene is HC, CH, you can tell, CH, triple bond is there, plus HBr, it will form bromo, it will form bromoethene. First it will form the triple become double bromoethene. Okay, means CH2 CHBr, and again further reaction, it will form CHBr2 CH3. This is the only important thing, sir. CHBr2 and CH3. That is a one dibromoethane. Here only you have to understand. This is according to the Markovnikov rule. Means both bromine join to the same carbon. Why? Because Markovnikov rule is there, that negative part will go where there is a less hydrogen. Then there was less hydrogen. Okay, because side other carbon 2 hydrogen was there, but where second bromine joined, both bromine joined there where less hydrogen was there. First they will equal was there, both side one hydrogen was there, but after joining one Br, then what happened? One CH was there, not become CH2, other become CHBr. Then now one carbon has two hydrogen, other carbon has one hydrogen. Then in second reaction with HBr, now that Br will go to the carbon which has less hydrogen. Less hydrogen. That's why there two carbon will be in the two bromine will be in the same carbon, because there only one hydrogen is there. Other carbon has two hydrogen. Now it became 3 carbon. After attaching it will become 3 carbon. Second reaction will take place. First reaction, one carbon has one methyl group, one hydrogen and one bromine. Okay. Then now second reaction will happen. Then bromine will go to that carbon which has less hydrogen. Then now double bond will become single bond, and one more bromine will attach to the carbon which has one hydrogen only, because other carbon has two hydrogen. Then now it became CHBr2, and other carbon which was CH2 now it became CH3. Hydrogen is absorbed there. Bromine went to the carbon which was having less hydrogen according to the Markovnikov rule, and this is called 1,1 dibromoethane. Okay, dibromoethane. Now other example you can take for propene. Propine you can take example. Then that CH3 has nothing to do, only they have increased the chain, length increased. Main reaction will be again as it is. But now you can see that methyl group is attached with the carbon. One hydrogen was there in acetylene. That H-con and methyl group is there. That's why it became propine. Then now that carbon has no hydrogen. One hydrogen was there, that is methyl group came in that place. Then now that carbon has no hydrogen, but other carbon has one hydrogen. And carbon-carbon triple bond is there. Then now here you see the situation. You might be understanding what will happen. Now in this situation, in case of propine, HBr is joining. Then where Br will go? Then Br has a negative part, Br negative, Br H plus, Br minus. Then this bromide will go to the carbon which has no hydrogen, because other has one hydrogen. Then there it will not go. It will go to the where hydrogen is less or no hydrogen. There is no hydrogen. Hence there it joined. It joined there. Okay. Means middle carbon. And H went where CH was there. There it went. It became CH2. And triple bond became double bond. Again, then now it formed 2 bromopropene. Double bond. Triple became double. 2 bromopropene. Now one more double bond is there. One more reaction can take place. Same way. Then now again one HBr is coming. Then again same way. Now again the middle carbon no hydrogen is there. And other carbon 2 hydrogen is there. Then where it will go? Then again, and it will also come in the same carbon, middle. Then now it became 2,2 dibromopropane. 2,2 dibromopropane. This is again according to Markovnikov rule. Okay. Now come to the addition of water. This is a very important reaction. And actually in village, people will use this reaction. Village people. You will tell how. Generally, for making lamp, you require kerosene, correct? Kerosene and thread you require, or cotton, to burn, correct? But here you will not require anything. Kerosene will not required, cotton will also not require. What will you require? That a small, you can say, any box you can take, container, any container, a small container, pack made up of tin and this anything you can take, or any metal, that you can take any container. There you can take the stone, calcium carbide CaC2 stone. In that, as you will put water, then reaction will take place. Already I told you, preparation of acetylene gas. Then gas will form. Actually, if you put the cover and one hole you will make in the middle of the cap, then as you will put water on the calcium carbide and you just close their mouth, one hole is there in the cover, then gas will begin to come, acetylene gas. There you put fire, then it will burn, and it will give light. Then in village, the peoples are using, sometimes in market they will use, when there is no current, no kerosene, then a calcium carbide is easily available, cheaper, hence they will use. But one problem is there, that the smell will be very bad. Garlic smell you will find. Okay. Now I am telling you addition of water. Then here, like alkanes and alkenes, alkynes are also immiscible with water and do not react with water. However, one molecule of water adds to alkynes. In alkynes, this reaction will take place. Okay, one molecule of water adds to alkynes on warming with mercuric sulfate and dilute sulfuric acid at 333 Kelvin to form carbonyl compounds. Okay, here you will get some compounds, but reaction will take place only by adding water. This is, if you want more quantity, continuous reaction, then this condition you have to apply. Okay, you want continuous and you can say particular product. You want particular product, then you have to this mercuric sulfate and H2SO4, dilute H2SO4 is required, and temperature is also there. If you want to get carbonyl compounds, then you have to these two condition you have to apply: mercuric sulfate and dilute sulfuric acid and temperature. Then you will get alcohol. Okay, you will get alcohol. Then ethine plus HOH. HOH means water. H2O. HOH. Then just like ethylene you have seen, same type of reaction will take place. One OH will join. Triple bond will become double bond. Okay, and in one carbon this OH will join, and another carbon hydrogen will join, HOH. OH will one carbon, other carbon H. Okay, and after that isomerization will take place, means rearrangement. Then it can form CH3 COOH, means ethanol. Aldehyde you will get. After OH was there and H was there and double bond was there, CH2 double bond and one carbon H and OH. OH just joined. I told you OH joined to one carbon, H gone to the other carbon. Then CH became CH2 CHOH, and on isomerization this CH2 will become CH3, correct, and OH will go H, CH2 became H, because that from the other carbon hydrogen was there, that it has taken. Then double bond, carbon double bond gone, it becomes single bond and it becomes CH3C. Then this hydrogen it has taken, that is from the OH, that hydrogen was taken. Then now it become only O, and that carbon double bond gone, and carbon and oxygen double bond formed, and other carbon H is there, hence CHO group developed. aldehyde group developed. Okay, hence it is called ethanol acetaldehyde. 2 carbon is there, that's why ethanol, Al, also called acetaldehyde. Like that way, another reaction also you can take propine, one methyl, one hydrogen gone and methyl group came. Then again here same type of reaction will take place, that OH will join one carbon, OH will join either other carbon, H will join. But here where OH will join? Where OH will join? 2 carbons are there. Then following the Markovnikov rule, where less hydrogen or no hydrogen is there, there it will OH will join because it is negative part, OH. Then now in propine, one carbon has, middle carbon has no hydrogen, hence there it will join OH, and other carbon, neighboring carbon, where only one H is there, then hydrogen will join. Then now it became CH3 COH. From the middle carbon OH joined, and where it was a CH, that became CH2, and triple bond became double bond. Again here also isomerization will take place. Means OH, that H will come to the where it was CH2, there it will go, and that was the double bond. The double bond C and double bond CH2 was there. Then that bond will become single bond, correct, and carbon oxygen will become double bond as previous. Carbon and oxygen become double bond, and carbon double bond now became single bond, and OH, H of OH, that will go to the H with CH2, that become CH3. Means now you got acetone. Carbon is in the middle, CO group is there. With that carbon, oxygen is attached with double bond, and both side CH3, it became acetone. And also you can tell propane, 3 carbons are there. Single carbon has single bond, only with oxygen is a double bond. Then it is called propanone, ketone. Okay, it is the first member of ketone, propanone. Now today again it will not finish all reaction, and next class I will continue. Now I am stopping only here. Thank you.